Hey, this is Mr. Schultz. This is a video on naming acids in particular. You'll want to read or at least refer to section 9.4 in your textbook or online. And specifically, table 9.5 has a lot of the same information I'm going to cover. It's on page 272. So please take a look at that. Pause the video, come back if you haven't already, or watch the video and then read it afterwards, whatever works best for you. All right, so in naming acids are essentially three different categories in which I can place acids. So I'm going to try and cover the generalities and the patterns that we use to name those. It takes a while to get the patterns, but they're pretty straightforward. So a little bit about acids before we get started here. Realize that acids typically start with an H. So if you have a compound that is H, then something else, we're going to consider it an acid. Once you see that H in the beginning, the anion, it's really the anion, so if you would circle that anion, it falls into one of the following three categories. Just so you know, technically speaking, when we deal with acids, if I have HCl AQ, that means aqueous acids are typically dissolved in water. So this would be an acid, and I would follow these acid rules. If it said HCl, like a gas or liquid or solid, some other state of matter, I would use the covalent naming rules. So everything we're dealing with is going to have an AQ on there. So if you see those symbols, that's what that means. Again, AQ indicates an acid. The first category that we fall into, if it starts with an H, we find some prefix and suffixes that are tied together. If your anion ends in IDE, so look at the second part of the acid. Again, they all start with H. Look at the second part. If the name of that anion ends in IDE, this is what you do to name it or figure out the formula. You start with the prefix hydro in the name. You add the root of the anion, that's the words before "ide", and then you add the suffix, the ending, IC, and then the word acid. So let me show you an example so this might make more sense. I have a compound in front of me. It starts with an H. Technically speaking, it should have a little AQ there to know it's an acid. So this is an acid now. Once I know it's an acid, I look at just the anion because they all start with H. That's what I want to find out. If I look on my anion sheet, or remember, this is called bromide. Again, it ends in IDE. Once I see that, to name this, because I have the formula, I'm going to follow my steps. Step one, I'm going to add the prefix hydro. I'm going to add the root. The root is what's left over before the ide. In this case, it is BROM. Throw on the ending ic, and then the word acid. So this is hydrobromic acid. Hydrobromic acid. And then this going the opposite way. If I see an acid, I know it's an acid because it says acid, of course. But if I see hydro and ic, this is important. This is the only time I have both a prefix and a suffix with an acid. It goes with the ending IDE. So I know the anion going the opposite way. The anion had to be an IDE ending. In this case, I'm going to take the root right here, that root, FLUOR, and throw the ending or the suffix "ide" on there. I know that fluoride is F-1. All acids start with H+. If I drop and swap, my formula for hydrofluoric acid is simply HF. So again, the connection you want to make in your brain for number one is that hydro space ic is interchangeable with the ide ion. Ide goes with hydro/ic. Hydro/ic goes with ide. That's case one. If you come across an acid, and again it's an acid because it starts with an H, so specifically if you find the anion ends in ATE, then I have to remember that I'm going to switch out the ate suffix with ic. So I made up this silly thing where I know that ic and ate are tied together, and ate and ic and ate goes with ate and ic. So my very silly thing is ick, gross, I ate it. So ick and ate are tied together depending on which direction I'm going. I'll give you some examples in a second here. So here are the steps. If the anion ends in ate, start with the root of the word of the anion and add with the suffix ic, and then add the word acid. So in this case, again, there's my H. I'm really interested in the anion, like I am for every acid. That anion, if I look on my ion sheet or I remember, this is called chlorate. Since it ends in ate, it falls into category number 2. I remember 8 goes with ic, 8 with ic with 8. I switch this out. Chlorate becomes chlor. There's my root. Ic. And I throw the word acid on there. So this is chloric acid. Going the other way, if I see ic on the end here, and notice the difference between group 1 and group 2. Group 1 had hydro and ic. Group 2 only has ic. There is no hydro at the beginning of this one. That's how you differentiate. So if I just see ic, then I'm going to have it go with 8. Remember, ic and 8 go together. This is where sulfur and phosphorus are a little weird. So if you went literally, you get sulfurate, but looking on your anion sheet, there's nothing like that. It's just sulfate, S-U-L-F-A-T-E. And sulfate is SO4 minus 2. We know it's an acid, so it has to start with H+. So that the cation is always the same for these. I drop and swap, and I get H2SO4. That is the formula for that acid. So I've got the ide ending goes with hydroic. I've got the 8 ending that goes with ic. And now my third category, look at your polyatomic sheet. What's the other polyatomic that we haven't covered yet? It is, in fact, ite. There are some anions that end in ITE. And so the other connection you have to make is if you see ITE, it goes with OUS. And OUS, or us, goes with ite. So my silly saying for this is, it's ite with us, like it's all right with us, you know, like keeping it cool. It's ite with us. So if I see an anion that ends in ITE, I start with the root of the word for the anion, and then add the suffix us. It's ite with us. So looking at this, again, I have an acid because that first thing is H. The name of this right here is actually hypochlorite. Now don't get confused. This is hypochlorite. This is just part of the name of the ion on your sheet. This has nothing to do with hydro. This has not anything to do with naming this group. It's just what it is. We're focused on the ite. So don't get too confused. The name of the anion is hypochlorite. Because I see ite, that's the focus. I know ite goes with us. So I'm going to go from hypochlorite to hypochlorus. That's the change right there. This is the big part. Don't worry so much about the hypo. And then throw on acid on there, hypochlorous acid. Again, hypo is there because it's just part of the name of the anion. Going down a little bit to hypobromous, going the opposite way. Again, hypo is not part of the naming of the acids. It just happens to be the name of some anions. So I see hypobromous acid. Since it's an acid, I know it will start with H+. I have to do some detective work and find out what is the name of my anion. It ends in OUS. Ite goes with us, so I switch that out, put hypobromite. If you look on your sheet, hypobromite is, making sure I have it right, BRO minus. I had to look myself, double checking. Hypobromite is BRO minus. And once I have those, I drop and swap. +1, -1 becomes H-bro. Alright, so those are the three categories. Again, hydroic goes with ide. That's category number 1. So if you see an IDE, those go interchangeable. Ic goes with 8 in category number 2. And then category number 3, ite and us go together.